Hey, it's Mr. Lum again, and we're going to be doing some more Math 9, and we're going to be doing some powers again. So last time we looked at exponents, and we talked about bases and exponents and powers and the different parts and what it means. And we're going to be doing the same thing again, but we're going to be looking at powers of 10. So I have a couple of examples right here. So I have some numbers written in words here and in standard form. And so here I have 100,000, which can also be written as 10 to the power of 5. And what that means is that it's 10 times 10 5 times. So 1, 2, 3, 4, 5. Okay? Now, when we have a number that's written like this, an easy way to think of it, if we want to go from a power and write it in standard form. So say if I had 10 to the power of 6, an easy way to go from a power and writing it in standard form when it's a power of 10, and this only works for powers of 10, is that I can just simply write 1, and then since I see this 6 right here, I can just write 6 zeros afterwards. So 1, 2, 3, 4, 5, 6. I wrote 6 zeros afterwards. Okay? And so that's going to be a million. So 10 to the power of 6 is the same as writing 1 million. And just write, like if I wrote 10 to the power of 7, I would just write 1 with 7 zeros afterwards, or in other words, 10 million. Okay, and we see this pattern kind of go all the way through here. So 10 to the power of 4, which is 10,000, is 1 and 4 zeros afterwards. We see 10 to the power of 3 has 3 zeros, 10 to the power of 2 has 2 zeros, 10 to the power of 1 just has 1 zero. Okay, so 10 to the power of 1 just means it's just like this. We have 5 tens. 10 to the power of 1 is just 110. Now, 10 to the power of 0, you can think of it as this way, as it is 1 with 0 zeros afterwards. Okay? And then we get some different kinds of things, and we can get 10 to the negative 1. And that's where you have to move the decimal in the opposite direction. So and we can kind of go in the opposite direction right here. So almost we're like putting a 0 in front. Okay? And we're going to be talking about another way that we can kind of do this. Another way that we can kind of do this is that, so I kind of said that 10 to the 4 is 1 with 4 zeros afterwards. Now another way you can do it is just kind of write 10 and then 1, and then you can just move, there's a decimal place naturally right here, and you can just move this 4 spaces, 1, 2, 3, 4. You can just kind of fill that in, 2, 3, 4. And so that's how we can kind of get this one right here, right? And 1, and then we have 0, so you just like move it 0 spaces, so it just stays as 1. Now when you have something like this, 0.1 or 10 to the negative 1, you have 1, and when it moves negative, just like a number line, right? So a number line looks like this, 1, and this one would be negative 1, right? You'd be moving it in this direction. So we move it in this direction, 1 space. So our new decimal point is right here. So it'd be 0.1, or in other words, 0.1. And same thing for this one right here. Our decimal place is naturally right here. We move it in this way 2 spaces. Okay, and so our new decimal point is right there, and we have 0.01. Okay. So we're going to kind of change paces just a little bit, and we're going to come back to that power of tens thing again. But we're going to talk about one of our exponent laws, and that's going to be the zero exponent law. And I have some kind of like notes here for you. So it says a power with an integer base other than 0, and an exponent 0 is equal to 1. And I kind of have like a little bit of a formula right here. So any number to the power of 0 equals 1. So when we have some number like this, so we have 3 to the power of 0, that just simply equals 1. Okay? Now, I'm going to skip this one just for now. Okay, and we'll come back to this. But here we have one, very similar to this one over here, but it's negative 3 to the power of 0. Now, this is just going to equal 1 as well. So this applies to negative numbers. So if it's a negative number and it's to the power of 0, it's going to equal a positive 1. It doesn't equal a negative 1. Now, this is going to be a little bit of an exception. This is going to be negative 1, so the answer is going to be negative 1. Now, we're going to take a look at why. So, when you have a negative in front of here, it's kind of like this. It's kind of like writing a negative 1 times 3 to the power of 0. And if we remember some of our BEDMAS stuff, first thing we're going to do is the exponents, right? So this would be like kind of negative 1, and we know that anything to the power of 0 is just going to be 1, and this we have negative 1 times 1, and that's why the answer is negative 1. Now, just like this part right here, we have negative 3, and then we have the 0 on the outside of the bracket. So just again, following BEDMAS, we're going to do inside the brackets first. This is kind of like a negative 1 times a 3, and everything inside of that brackets is to the power of 0, and so that's why this one is a 1, and this one is a negative 1. Okay, and so this will be a very common question that you'll see on a quiz or a test, and it's a common mistake to be dropping some of those negatives. Okay, so we're going to do a little bit of practice. This is where you can put it on pause, hopefully, and you can answer some of these ones right here. And hopefully, now that you've unpaused it, we can figure out what some of these numbers are. So we're going to evaluate each power, which kind of means write it in standard form. And again, just like before, we write 1 with 7 zeros afterwards. So 1, 2, 3, 4, 5, 6, 7. And just to help us count it, we can put some commas in there. So that's going to be 10 million. The next one is anything to the power of 0 is just going to be 1. Or you can just write 1 with 0 zeros afterwards. So this will be 1. Okay. 10 to the power of 2 is 100, or 1 with 2 zeros. And you can also think of it as 10 times 10. And hopefully we know that 10 times 10 is 100. Okay. Now, hopefully you're able to do this one. 3 times 10 to the power of 3. So we're going to write this in standard form. And sometimes writing it in this method, some people call it scientific notation. But first we're going to just do this 3, and then we're going to go times, and then we're going to go 10 to the power of 3. Okay, so 1 and 3 zeros afterwards. So now we're just going to go 3 times 1,000, and that equals 3,000. Okay, so same thing for this one right here. We're going to go 2 times, and then this number, we've already talked about it up here, is going to be 2 times 100, or in other words, that's just going to be 200. Now, same thing, we've just finished answering this one, so we know that this one's going to be 3,000. Okay, so 200 plus 3,000, well, that's going to be 3,200. Okay. So now we're going to go the other way, and we're going to write these numbers to the power of 10. Okay, sometimes we call it scientific notation if you're in a science class or a chemistry class. So there's a few different ways to do it. I'm going to show you one way. So kind of like, just like in the slide before, we know that this is in the hundreds. So you can say that, hey, I know this is in the hundreds, so this is going to be to the power of 10 to the power of 2, because that's the hundreds right there. And then we can just say that one number in front, and we're just going to go 2 times 10 to the power of 2. Now, there's a little bit of an easier way, and this is kind of the method that most people do, is that we just find where is the decimal point here. So we know that the decimal point is right here. We just don't bother writing it. And now what we do is we're going to move the decimal point so it's right after the first number. So we're going to move it 1, 2 spots. So now it's right after that first number right there. And so we just write 2, and then we write that decimal point right there. Okay? And since we moved it 2 spots, we write times 10 to the 2. And you get the same answer, of course, and you don't have to write that decimal point. Now, we're going to do the same thing here. We have a big number, so we're going to move this one kind of going 1, 2, 3, 4. So just like before, I move the decimal right after the first number. Okay, I count how many times I moved it. 1, 2, 3, 4. So I know that this one is going to be times 10 to the, since I moved it 4 times, I write 4 right there. Okay. The other way you can think of it too is that this is in the tens of thousands, so that's why we're going to be writing times 10 to the 4. Now, since I moved the decimal point right here, their new decimal point is right there. So now we have to just write that number in front of here. So it's going to be 5, and I write point, because the decimal point moved there, 2, 4, 1, 3. So 5.2413 times 10 to the 4. Same thing for this one right here. We're going to move the decimal point over. Same thing, we've moved it 4 times, so that's going to be a times 10 to the 4, which is in the tens of thousands. This is 32,000. Since we moved it all the way over here, their new decimal point is right in that location right there, so we're just going to write that there, 3.2. Okay, so it'd be 3.2 times 10 to the 4. Now, if you wrote this, 3.2000 times 10 to the 4, it is technically right, but it's just a little bit cleaner if we get rid of all those zeros. Okay? So we don't have to write all those zeros, because these two numbers are actually equal. You can't do that with this number. You cannot write 5.2 times 10 to the 4, because these two numbers are not equal. Okay, these two numbers are equal, but these two numbers aren't equal, so you can't be doing this one like that. Okay? So, I would like you to get some practice in your Math 9 textbook and work on page 61. Just a few questions. It should only take a few minutes. And I'll see you in the next video.